Hey, how's it going guys? My name's Daniel, aka HashLips, and welcome back to my channel. I'm very excited for today's video because I'm going to show you an automated way to run, manage, and deploy your collections. I usually build interesting projects such as the art engine that's well known in this space, especially in the NFT space. And you can go and check it out at the HashLips GitHub repositories over there. Also, if you find an interest and want to know more about NFTs, go ahead and watch some of my other videos. The videos I put out here are designed in a beginner-friendly way. This video where we are going to be discussing automation in this space, especially when deploying a contract from the terminal, is more designed for experienced developers, people who know their way around the terminal. It doesn't mean you can't attempt this, but just keep that in mind. If you are a beginner, I would highly recommend rather going to this video and watching how to create an NFT collection, the ultimate guide. This video was designed for beginners. So go and check it out if you do not know what we are going to be discussing today. Later on, when you have more experience and you want to attempt something more challenging, come back to this and watch this video. So, we are going now to create an ERC-721 smart contract that's an NFT contract that will live on the Ethereum blockchain. What's cool about doing it this way is everything you're going to do with me today is going to be automated. It's going to be a smart contract that facilitates whitelisting, pre-sales, public sales, and these cool things can all be run from your terminal. This is something a bit more advanced, so like I said, hold on to that seat of yours because we're going to dive in deep. First things first is go to this collection, NFT ERC-721 collection. If you go here, or you can go directly to the URL here at the top. Once you are inside this repo, then you can either git clone this to your machine by clicking over there, saying git clone and using git, or you can download the latest release, which we are going to do right now. I'm going to click on the release version over there. Then let's kick off the download by clicking on the source code. While we wait for the download, I want to take this time to say thank you to Marco. Marco is actually the reason that this collection exists, and here is his YouTube channel. Marco gives dev tips on NFTs and so on, and we will be working together quite closely in regards to the HashLips Labs, where we will be putting out code bits and pieces, open source of course, for people to use in the NFT space. So I just want to say thank you to him because he's an amazing dev. Alright, let's carry on. This process only takes about 5 minutes. But in this video, it's taking a bit longer because I want to make sure that you understand this fully and have all the dependencies. Yes, we have to have all these dependencies. So let's go ahead and install Node.js first of all. Secondly, you will need to have an IDE. I'm going to use Visual Studio Code so you can download this, but any IDE will work. You will also need to sign up to Infura. Now Infura is going to be our connection to the blockchain, and once you've signed up, it's free. You can choose the free plan. We can go to the dashboard. Once we're here, you can see that we need to create a new project. So click on create new project. The product is going to be Ethereum, and we're going to give it a name. I'm just going to call this my ERC-721 and click on create. Once your project has been created, you will see a page like this. Please don't share this information with anyone else but yourself because this is sensitive and I'm going to delete this project after this video. This is just for testing purposes. Pay close attention to this endpoints tab over here. We are currently on the main network. Then we also need the Rinkeby test network, and we will need both this endpoint as well as the main network so that we can configure our application. Let's keep this tab open for now. Next, what you want to do is go to etherscan.io and sign up. I have signed in, and now if I hover over my icon and my username, I can go to the API keys. This is important for us to have an API key, and the reason is so that we can verify our contract straight from the program. This is very cool, and I'll show you that later in the video. For now, go here on the Add button and create a new API key. I'm just going to call this my-ERC721. Create new API key, and there it is. All the information that I'm busy showing you is sensitive information, and I will be removing all my API keys after this video. So there's no point in trying to use any of the API keys or tokens that you see in this video. As we all know, NFTs need metadata. And before you can deploy your contract, you need some sort of metadata. So my metadata and images, along with the hidden metadata and image, are saved on Pinata, a pinning service that links you to the IPFS network and gets your images and metadata stored on the decentralized network. Now, if you want to know how to get this part set up, like I said before, I highly recommend watching that ultimate guide video over there. To create the NFTs, I highly recommend watching this purple collection of videos, Create 10,000 NFTs, whether it's any of these tips and tricks. You will learn a great deal on how to create this. Then, I would like to recommend that you watch something like how to upload large files to IPFS so that you know how I got the data on here. The ultimate guide does explain that, but this is not the topic for this video. It's simply just a requirement that you already need your metadata set in place. Now it's time to extract the file that we have downloaded. Here we go. We have our new project over here. What we need to do now is open this up in Visual Studio Code. So let's go ahead and open Visual Studio Code, click on Open, and then find that directory. There it is. Click on Open, and here is our project. Before I go through the project structure, it is important that you might need to install this extension called Solidity. This extension, however, I already installed it. You can just search for it here at the top and then click on Install. This extension helps you with code completion and snippets with the Solidity programming language if you need to update the contract yourself. You can then close this off and go back to the project. Next, let's install Yarn. So open a new terminal, and the latest way of installing Yarn is basically running CorePak enable, because Yarn is now shipped with Node.js in the CorePak feature. If your Node version is greater than 16.10, you can run this command, and if it's before 16.10, then you can run npm-g CorePak. Let's go and check what version we have. In the terminal, I can just run node-v, and we can see that I've got version 16.13. So all I need to run is CorePak enable. So I'm going to go ahead and do that. Click enter, and it says internal error access permission. So what I'll need to do is run sudo before this and then run CorePak enable. It's going to ask me for my password. I'm going to enter it, and there we go. To test if Yarn is successfully installed, I can now run yarn and then -v, and it should give me a version. There we go. I've got version 1.22.15. Now we can run the commands and use Yarn as a package manager. I have now cleared my terminal by pressing Command K. Now that we have a clean terminal, we can go and look at the project structure. We have a few folders and files, and basically we've got some GitHub test configuration as well as VS Code configuration explaining the spaces that we can work with in our files. Then the two most important folders, which are the minting dApp as well as the smart contract, a license and a README file. The two most important folders are this smart contract as well as the minting dApp, and we will start our journey on the smart contract folder. In this folder, or should I say project, we're going to set some configuration and then deploy the contract. Later on, we're going to go into the minting dApp and build our app. Now, I want you to understand that these are technically two different projects, but they're in the same project as a whole to make it easy for us to deploy a contract as well as a minting dApp and make that connection. So currently our terminal is in the root folder, meaning this outside part. You need to go and say cd, and then we're going to try and go to the smart contract. So cd smart contract / hit enter, and now you can see we technically inside the root folder of the smart contract. When you are in here, it is crucial to install the dependencies. You can do that by simply running yarn and click enter. This will install Hardhat and all the dependencies needed for us to deploy the contract and work with Solidity. Now that we have run yarn, we can see that it is done, and we find an extra folder called node modules. This is now all the dependencies that we'll need for our project. Furthermore, you can see we have a configuration folder which we'll dive into later. This defines the config as well as the whitelist for our contract. Then we have the contracts folder, which contains the ERC721 smart contract. This contract comes with a whitelist feature that uses a Merkle tree that I'll show you how to use later on. I want to say at this point that this is a low gas contract and everything works fine. But I am an educational channel, and I have to say that you need to do your own due diligence before using anything I show on this channel in production. I do this for educational purposes only, even though the code is pretty cool and works because we have tested it. But I have to say that because I just want to make sure that if something breaks, I don't get into trouble. That being said, however, feel free to play with the contract, change it up, and test it out. This is a great way to start getting into Solidity development with Hardhat. Now, at the very bottom of this contract, like always, I've left in this 5% going towards the HashLips organization if you decide to use the contract as is. We appreciate that because it shows the support to the HashLips organization, and we do use the funds to further our development and contribute to the open source code. So thank you for those people who have left this part in here. If you do not want to contribute, simply you can take this part out and everything will still work fine. Please remember to just leave this, otherwise you will not be able to pull out any funds. Leaving in this section means a tremendous amount, and I hope to soon one day buy a pink and yellow Lamborghini. But all jokes aside, we can now close this contract for now. The lib folder just contains some libraries and interfaces that this program uses. We have our node modules, the script that actually executes different pieces in the smart contract, and then our tests. A very important file is this env.example. What you need to do next is copy and paste this file. Then edit the name and take out everything up until the env part. So you just leave .env. This file is excluded by the gitignore. So with gitignore, it will not upload this to GitHub if you accidentally push this to GitHub. This is very important, and I'm going to stress something now, and I'm probably going to talk about it over and over, but I cannot stress this enough that you should never ever share this file after filling in the details with anyone, because you will be putting in your private key of your wallet address in order to deploy your contract on the blockchain. I highly personally recommend after doing this part to delete this file and every time fill in the details again when you want to go and update something or deploy another contract. If anyone ever asks you to show them the Env file or this information, please tell them to go away, because that guy is trying to scam you. So never show this to anyone. I can show this because this is dummy data, and I'll also be using a burner wallet so that I can do this tutorial. Now that that's understood that this is very secretive information, so I actually recommend maybe starting up a burner wallet, sending it some ether, filling in the details, deploying the contract, and then maybe transferring the ownership. That might be a better and safer option as well. However you do it, please just keep this information safe. Now let's go ahead and fill it in. You can see here at the top we need the collection's URI prefix, which is the revealed metadata. We can grab that by going to the pinata that you have set up and was the pre-requirement, and I need this metadata, so I'm going to copy that, then go back to Visual Studio and paste it in here, leaving the / for the Rinkeby test network as well as the main network. We will need the private key of a wallet as well as our Infura link. Let's go to Infura, and it was here, and as you can see, this is the endpoint we will need to use. I'm going to copy this, go back to Visual Studio and paste this here on the main network, then go back and go to Rinkeby, and then simply go and copy my Rinkeby's endpoint as well and fill it in here at the top. Now I need a private key. Like I said, here I've got a burner wallet that has some test ether in this, so I'm going to copy that, paste it here as well as here. Now we have the main network as well as our test network set up. Keep in mind, if you are planning on only testing your collection, you simply have to only fill in the test network details. You can have a different wallet for your main network as well. Then we get this gas report to coin market cap. This is used for actually setting up some stats regarding the minting fees and those kind of things. You can actually watch a video that Marco will bring out that gives an in-depth explanation on this key. For now, we're going to skip this because it's not really necessary. We lastly need the Etherscan API. So we need to go back and get our API key. So go to Etherscan, and I'm going to copy my Etherscan API key. You should copy yours and go and paste it in here. Now I've got my .env file set up. We can now close this file, go to the config folder and click on this collection config.ts file. This is the last bit of configuration that we'll need to set up, apart from these variables here at the bottom, to deploy our collection. Right here at the top, it says we should not change the contract name manually. This is because we need to run this command over here. So copy this, go to the terminal, and I'm just going to click Command K to clear it, then paste it. Then let's go ahead and rename our contract. I'm going to call my contract my ERC 721, and this is Pascal case, at least to the abbreviation point, but keep it Pascal case just to follow convention. Do not use dashes or underscores or make it something weird, because it might break the program and then you have to do this all from the start. So hit enter and let's see if it will rename all the instances. And there we have it. It says that it successfully renamed everything from your NFT token to my ERC 721. Not a creative name, but indeed it worked. It also recompiled, seeing that there was a change, and now we can move forward to our next step. We can also see that here on line 8, it's now called my ERC 721. Now that we have that, the rest of the configuration is pretty straightforward. For the token name, I'm going to maybe change it to my ERC and then 721, again, not too creative, but you can maybe call it the Flying Monkey Ape Club, who knows. And then for my abbreviation or my symbol, I'm just going to make it MERC, and that's fine. Then we need the hidden metadata URI. We need to replace the CID, so let's jump back to Pinata. Let me get my hidden metadata, copy that, go back to Visual Studio Code, and paste it in there. For my collection, because it's a small collection of 12, I'm going to enter 12 over there. For the whitelist, pre-sale, and public sale, I'm going to leave the default values. Basically, when the contract is in whitelist stage, the price and the max amount per transaction will be as follow. And the same for pre-sale and public sale. Now, these last three, well, the last two variables, we're not going to set yet. We're only going to set the contract address once we have deployed this contract, and the OpenSea slug once we know what the collection is going to be called on OpenSea. This is for the minting dApp. Then the whitelist address. You can go ahead and look at this whitelist.json. This we'll get to in just a second, but you can fill this out so long, or you can also change this and update it even after your contract is deployed. Now we are ready and for the real fun to begin. I am now simply going to run a few commands in the terminal and get our collection deployed as well as verified. So how we go about this, and just to mention, if you want to know where these commands live, if you go to the package.json down here, you will see the commands listed in the scripts section. Well, let's just go back for now. And what we need to do down here in the terminal, once we have configured our config, simply type yarn deploy. Then you need to specify the network, so -- network, and which network you want to deploy this contract on. So if you have configured the test network as well as the main network, at this point, if you want to do the test network, you can type in Rinkeby, or if you want to do the main network, you type in mainnet, like so. And we're going to be doing Rinkeby, so Rinkeby, and now I'm going to hit deploy. Press enter and watch the fun begin. So it says no need to generate any new typings, which is just the program running through its stages, kind of informing us what's happening. Currently it's being deployed, and what we are waiting for is an address to be returned. That address will be the address of the contract. So let's give it a few seconds. This might take some time, so go and get a cup of coffee, and hopefully once you're back, you will have your contract address. And there we go. It is done. So here is the address of our newly deployed contract on the Rinkeby test network. And if you were to have said main network, it would have been on the main network. Keep in mind that the private key that you have specified in the .env file, that address or that wallet will need to have Ether in it. So either test Ether or real Ether. Otherwise, this process won't work. I can now simply copy this address and paste it here on line 26. So let's paste our address in there, make sure it's a string, and save the file. I can also go back and go to the browser, go to the Rinkeby test network on Etherscan, and scan for my contract. If I search for this, here is our newly created contract. If we go to the contract section, we can see that it's not verified yet. Let me show you how to verify this contract straight from your terminal now. Let's go back to Visual Studio Code, and in the terminal type the following. So type in yarn, then verify, specify the address, which is this one over there, and then lastly say dash dash network, and the network where you want to verify this contract on. Because we have deployed this on the Rinkeby, we need to specify Rinkeby network. So now I'm going to hit enter and let's watch the process take place. We're going to wait and it's going to reach out and try and verify our contract. That's why the API key from Etherscan was so important. Here it's going to verify and it's saying verification on Etherscan, waiting for verification result, and fingers crossed that we get a verification success, but this process should work smoothly. And yes indeed, it worked like a charm. We have now successfully deployed the collection with one line of terminal code, as well as verify the collection with another command. Now, this is the power of this library. I know it took a while to set up, but once everything is set in place and you are used to the process, this is how easy it can be. And that's why I say that you can deploy a collection within 5 minutes or even less. Now, let's go ahead and go and check out if it's verified. If we go back to Etherscan, we can refresh and see that there our contract has now the green tick, but not only does it have a single file, it has all the separate files that it needs, like a proper contract and a verified contract should look like. How wonderful is this? We even have our arguments here at the bottom and everything looks great. And that is it. Now it's time to move over to the dApp and how to set that part up. Okay, so now we are back in our app. Remember, we are currently sitting in the smart contract folder based on where our terminal is pointing. And you can see that by this smart contract prefix. We're going to open a new terminal over here and then split the screens. Here you can see we are still in the smart contract. So what we'll need to do is say cd ... which means we go back to the root folder. We now need to go into the minting dApp. So then cd minting dApp /. There you can see we are now in the minting dApp on this side of the terminal and still in the smart contract on the left side. It's better to have this because we need to update the smart contract and we can see that reflecting in the dApp. The next step is to run yarn again, because remember, we are now in a separate project and it has its own dependency tree and it needs to go and grab that. So just wait for yarn to go and fetch all the dependencies, and then we're going to simply run yarn dev server to start up our development app. Now that the dependencies have installed, what we can do now is run yarn, then dev-server. Once we do this, yarn will spin up a dev server for us and it should open it in our browser. So I just got a notification telling me that it's trying to open it. So let me go actually ahead and open it on this port over there. So I'm going to just copy that. Pasting this in your browser will open up the minting dApp. Now, if you change something in the file, it will live reload and we can connect our wallet. Now, this is the dApp and you can feel free to change the UI to your needs. I'm going to connect my wallet and this is on the Rinkeby test network. So I'm just going to say next and connect. And here we can see it says you are not connected to the main network. You're currently on Rinkeby. Just a nice message letting us know this is the test app. We can see this is the wallet address. And here we can see total supply is 0 and the status is closed. How do we open this? Well, let's start with our whitelist sale. So let's go back to Visual Studio, and on the left side of the smart contract app, we can run the following command. If you do not know what the commands are, you can go to the package.json, and then here in the script, here are the following commands that we're going to run. We have whitelist open and close, and the pre-sale and the public sale open and closed. The only difference between pre-sale and public sale is the price, but the whitelist always needs to be closed before you do a pre-sale or a public sale. We're going to start with this whitelist open. So all you need to do now is in the terminal run yarn and whitelist open, and then you can just specify the network. So -- network and then Rinkeby. Hit enter. This is now going to try and open the whitelist of our contract. We can now see that the whitelist has been opened, and we can also see that the root hash has been updated. The root hash has all to do with the whitelist.json file over here. Every time this file changes and you run the same command, it will update the whitelist. Let me illustrate this. We're going to go now back to our app and reload it. It's going to say loading collection data, and now because the sale is open, we can see that it's only whitelist. Therefore, I do not have a minting button because my current wallet over here is not part of the whitelist. Let me go ahead and copy this and then go to the app and replace my wallet address up here. Save the whitelist.json, and inside this terminal on the left hand side, let's run yarn whitelist open network Rinkeby again. Let me go and press enter and wait for the transaction to take place. And there we have it. The root hash was updated again, and if we go to our dApp, we can now see that I am able to mint on my wallet. So I can click on mint, and then MetaMask should pop up with the correct price, and I'm going to say confirm. Now let's wait for my mint to take place. What I can do in the meantime is go to the contract address where I have gone before on Etherscan, the Rinkeby version, and then let's go to the transaction section. Let me refresh and let's look at the transactions that's been taking place. We can see that the set Merkle root was updated and then the whitelist was enabled. When I updated the whitelist, the set Merkle root was called again to update my whitelist list. If we now refresh the page, we can see that the whitelist mint took place and that I have actually paid 0.05 Ether, test Ether, for my NFT. We can also now see that the token tracker pops up because the very first NFT was minted. And this should now show up on OpenSea and everything should be fine. This is kind of the process what you'll go through in managing your NFT launch. For instance, next, what you might need to do once your whitelist is done, you will go and just change this function to close. You'll hit enter and this will close your whitelist. Remember, go to the package.json to see what you want to do next. I want to maybe open my pre-sale, and once this is all done, there it's saying disabling whitelist sale. Once that is complete, I can run the pre-sale open. So now that the whitelist is disabled, the whitelist sale has stopped, I'm going to run yarn and then pre-sale open, and remember your -- network should be on Rinkeby. And remember, if you're using main network, just to run the main net. So now we can see that the price has indeed increased, as well as the max per transaction, and the pre-sale is now open. It is good convention to close the pre-sale and then open the public sale again. So let's go ahead and look at our minting dApp. and we can refresh it, and the minting dApp should respond accordingly. So loading, it says sale is open. So technically, if I now switch to a different wallet, for instance this one, and I connect, and then I refresh, it should still say open, and I should be able to mint on this address too. And that is it. That is how simple it is to manage the contract from the CLI. Keep in mind, from this point onwards, you can always use the contract write functions to handle your contract as well, directly in Etherscan. So there are variants of options for you now to choose from. The last step, of course, for you will be to open the public sale, close it again, and then similarly run yarn reveal at the end of your sale -- network, and then you specify the network again, which is Rinkeby, and then hit enter. This will reveal the collection's metadata, so please make sure that it's either sold out or implement some hidden feature which I've shown in my previous video, or you can see on Marcus' channel as well. As you know, we've been testing in a development space with a development server, but you probably want to host your dApp on a web server, so that the whole world can see it. To build it, you can simply go on the right-hand terminal over there while you're in the minting dApp root folder. And if your server is still running, press Command C to just exit out of it and run yarn space build. Once you do this, it will build your application, and where you will be able to find it is in the minting dApp folder under public, and there you go. You have your index.html, and you can just upload that to a web server, and there it's done. And that is it. That is how simple it is. Keep in mind, every time that you update your whitelist and you run whitelist open, that you'll need to do a new build, just so that everything stays in sync. As an added bonus, if you feel like your .env file, is not too secure, or you might have shared that with someone and you still have the control over that wallet, at least you can go to your collection and connect on Etherscan, and then just go down to transferring the ownership. This field will be empty, but you can transfer it to a new owner as long as you are connected with that actual private key on MetaMask. And that is it. I hope you guys enjoyed this tutorial. I urge you to go and support my channel as well as Marcus' channel and really live the NFT world, where we will keep on bringing out open source solutions for you guys. I hope this was informative, and for more interesting videos, Marco will also be bringing out some cool content, so keep an eye out on my Twitter so that I can share those to you. I hope you have an amazing day. Until next time, cheers for now.